तो हम लोग का एग्जाम्पल है कुछ, उसके बाद कर्वेचर टॉर्सन क्या होता है उसको देखेंगे, एंड आफ्टर दैट वी विल सी सेरेट फ्रेनेट फार्मूला. So for example, show that the binormal at a point P of a given curve is the limiting position of the common perpendicular to the tangents at P and a consecutive point of the curve. देखिए solution. The tangent vectors at two consecutive points Pt and Qt plus delta t are r dot t and r dot t plus delta t. टाइम t है, t plus delta t है, तो दो हमारा tangent vector मिल गया. Therefore, the common perpendicular to these tangent vectors क्या होगा, is parallel to the vector r dot t cross r dot t plus delta t. Because this vector is parallel to both r dot t and r dot t plus delta t, so we can write it as the common perpendicular is parallel to this vector. That is parallel to the vector r dot t cross r dot t plus delta t minus r dot t by delta t. Why? Because this r dot t cross r dot t will be 0, so it is just the same. The limiting position of this vector as delta t tends to 0, delta t tends to 0 ले लेंगे तो क्या हो जाएगा, r dot t cross this will be r double dot t. But this vector r dot t cross r double dot t is parallel to the binormal at P. क्या है, P पर हमारा जो बाइनॉर्मल है उसके पैरेलल हो गया r डॉट टी क्रॉस r डबल डॉट टी. तो हमारा फिर रिजल्ट मिल गया कि बाइनॉर्मल क्या हो गया, लिमिटिंग पोजीशन है कॉमन परपेंडिकुलर का. तो दिस प्रॉब्लम इज सॉल्व. नेक्स्ट वी हैव कर्वेचर एंड टॉर्सन. सबसे पहले कर्वेचर देखें. द आर्क रेट ऑफ द रोटेशन ऑफ द टेंजेंट, जो टेंजेंट है उसका रोटेशन का आर्क रेट मीन्स डी टी बाई डी एस. आर्क रेट हो गया तो इट इज डी एस और टेंजेंट हो गया तो डी टी. तो डी टी बाई डी एस मीन्स आर्क रेट ऑफ द रोटेशन ऑफ द टेंजेंट is called the curvature vector or sometimes circular curvature. Its magnitude is usually denoted by this k. This is called as kappa. Thus by definition this kappa is equal to modulus of dt by ds. तो kappa हमारा magnitude हो गया and this is our vector. Let t and t plus delta t denote the unit tangent vectors at two consecutive points p and q respectively, and delta t with the theta with the angle between these vectors. देखो, this is your t, this is your t plus delta t, and this is your angle delta theta. Since am and al they are unit vectors, therefore the length of am and al will be 1. So if the vectors al and am are respectively equal to the vectors t and t plus delta t, then delta t is the vector lm. Delta t will be what? This vector lm. Use triangle law of vectors, and delta theta the angle between these vectors LAM. Hence modulus of delta t is equal to LM, and this is nothing but LM, 2 into sin delta theta by 2. यहाँ A से LM पे एक perpendicular draw करो, तो this angle will be delta theta by 2, this is delta theta by 2. So this length of perpendicular is AM cos delta theta by 2, and this half portion is AM sin delta theta by 2. Similarly, this is AM sin delta theta by 2. AM is 1, so the whole length will be 2 sin delta theta by 2. Therefore, modulus delta t by delta s is equal to sin delta theta by 2 by delta theta by 2 into delta theta by delta s. Therefore, kappa will be mod dt by ds. So it is limit delta t by delta s. So it is limit delta sin delta theta by 2 into delta theta by delta s. Limit of this one is, and so this is limit delta theta by delta s means d theta by ds. तो कप्पा इज योर डी थीटा बाई डी एस, यानी कि कर्वेचर हो गया डी थीटा बाई डी एस. द रेसिप्रोकल ऑफ द कर्वेचर इज कॉल्ड द रेडियस ऑफ कर्वेचर. रेडियस ऑफ कर्वेचर will be 1 by kappa means ds by d theta. and is usually denoted by rho. Thus rho is equal to 1 by kappa. के बाद है एक theorem. A necessary and sufficient condition for a curve to be a straight line is that the curvature kappa is equal to 0 at all points of the curve. यानी कि कर्व अगर स्ट्रेट लाइन है तो कर्वेचर कप्पा 0 होगा, और अगर कर्वेचर कप्पा 0 है then the curve will be a straight line. See the necessity part. Let the curve be a straight line. मान लिया कि वो स्ट्रेट लाइन है. Its vector equation can be written as r is equal to s into c plus d, where c and d are constant vectors. हम लोग पीछे देख लिए कि equation of a straight line is of this form. Hence t is equal to r dash. तो r dash में इसको differentiate करेंगे तो it will be s, it will be c, and t dash will be r double dash. R double dash means 0 because differentiation of this constant is 0. It follows that kappa is equal to modulus of t dash. Modulus of t dash means modulus of 0, so it will be 0. Means curvature is 0 in case the curve is a straight line. See the sufficient part. Let kappa is equal to modulus t dash is equal to 0 at all points of a curve. This implies that t dash will be r double dash and it is 0. Now integrate this equation 1, then you will get r dash is equal to c. Again integrate and we will get r is equal to c into s plus d. Here c and d are arbitrary constants. The equation 3, it represents a straight line for all values of c and d. Hence, the curve will be a straight line. It means if the curve is a straight line, kappa is 0, and if kappa is 0, the curve will be a straight line. So this completes the proof of the theorem. इसके बाद है torsion. The torsion at a point P of a curve is defined as the arc rate at which the oscillating plane turns about the tangent as P moves along the curve. Its magnitude shall be denoted by tau. Thus, the torsion at P is the arc rate of the rotation of the binormal at P. Hence, by definition, tau is equal to modulus dB by ds. क्योंकि अगर ऑस्कुलेटिंग प्लेन टर्न करेगा तो बाइनॉर्मल भी टर्न करेगा with the same angle. That is why this tau is equal to dV by ds, because it is the arc rate at which the oscillating plane turns about the tangent. If delta phi is the angle between the binormals at two consecutive points, दो consecutive point पे अगर delta phi angle है binormals के बीच में, then as in the case of curvature, पीछे हम लोग देखे tau will be d phi by ds. So kappa is d theta by ds and tau is d phi by ds. The reciprocal of the torsion is called the radius of torsion and is usually denoted by sigma. So sigma will be 1 by tau. और radius of curvature क्या था? रो था 1 by kappa. Skew curvature क्या है देख लें. The arc rate of the rotation of the principal normal which is perpendicular to tangent and binormal both. That is dn by ds is called the skew curvature and its magnitude is given by under root kappa square plus tau square. Now there is a theorem. देख लेते हैं. A necessary and sufficient condition that a given curve be a plane curve is that tau is equal to 0 at all points. देखो necessary part. Let the curve be a plane curve. Then the osculating plane at every point of the curve is just the plane containing the curve and is therefore fixed. अगर कर्व एक प्लेन कर्व हो गया तो हमारा ऑस्कुलेटिंग प्लेन भी फिक्स हो जाएगा. This implies that the unit vector b along the binormal is constant. जो binormal के along unit vector वो भी constant हो जाएगा. Consequently, tau is equal to dB by ds will be 0. तो first necessary part proof हो गया. Next है sufficient part, like tau is equal to 0 at all points of the curve. कर्व के सभी पॉइंट पर tau 0 है. This implies that dv by ds is equal to 0. So it follows that b is a constant vector. Since dv by ds is 0, therefore b is a constant vector. Now dds of r dot b क्या होगा? dr by ds dot b plus r dot dv by ds. So this is your t dot b plus r dot b dash, because this dr by ds is t. Since t and b are orthogonal, therefore t dot b will be 0. So this will be 0. And b dash means dv by ds is 0. So this is also 0. It means d by ds r dot b is equal to 0. This gives r dot b is equal to a constant. Since b is a constant vector of magnitude unity, r dot b is the projection of the vector r on b and is therefore the same at all points of the curve given by 1. यानी कि r डॉट बी क्या होता है? प्रोजेक्शन हो जाता है वेक्टर r का b पर. शुरू में हम लोग देख लिए थे सबसे पहले क्लास में. And is therefore the same at all points of the curve given by क्वेश्चन 1. This implies that the curve must lie in a plane. तो कर्व क्या होगा? इसलिए एक प्लेन में लाई करेगा. इसके बाद हम लोग का सेरेट फ्रेनेट फॉर्मूला है, लेकिन इसको हम लोग आज नहीं देखेंगे. इसको हम लोग नेक्स्ट क्लास में देखेंगे. अभी तुम लोग इसको नोट कर लो. कोई अगर क्वेश्चन है, क्वेरी है तो मुझे पूछो.